It's your boy Master929 and I hope you're doing well. So on this video, I will be focusing on the nature of the root. So now we use discriminant to determine the nature of the root, and the discriminant it is given by this formula, whereby we have delta is equal to b squared minus 4ac. So now by the end of this video, you will have to be able to understand and interpret this diagram. So now you can see that discriminant can be into two ways. You can see that when the discriminant is less than 0, meaning when the discriminant have a negative number, we are going to have no real root. And when the discriminant is greater or equal to 0, we are going to have real roots. And again, you can see that when we have real roots, we can have what? We can have the discriminant whereby it is greater than 0, and we can have the discriminant whereby it is equal to 0. And when it is equal to 0, it means we have what? Two equal real roots. Then when the discriminant, it is a positive number or anything that is greater than 0, it means that we have two unequal roots. And again, when we have two unequal roots, we can have what? We can have rational root, and we can even have what? Irrational root. So when we have irrational root is when our discriminant is not equal to a perfect square. Remember that a perfect square is a number that is obtained by multiplying an integer by itself. We are talking about both 4, 9, 16, 25, 36, 64, 81, like those kind of, or those type of numbers. And when the when we have rational root is when our discriminant is equal to a perfect square. So now let's look at the following examples whereby we are given this discriminant and we have to find their nature of the root. So for example number 1, we are given that the discriminant is equal to 0. And when the discriminant is equal to 0, you can see that from the diagram, from here we are going to take this root because our discriminant is equal to what? Is equal to 0. So meaning so far we have what? We have real roots. And from here we are going to take this root because our discriminant is equal to what? Is equal to 0. So meaning at the end we can conclude that our discriminant, our nature of the roots are two equal real roots. You see? So now let's quickly jump to example number 2, whereby our discriminant is equal to -8. So back to our diagram, you can see that from here we are going to take this root because our discriminant is a negative number. It is less than 0. So it means that we can conclude that the roots or the nature of the roots for number 2 are no real roots. Or we can say that we have non-real roots. Then number 3, we have discriminant is equal to what? Or being equal to 25. This means from here we are going to take this root because we have a positive discriminant, or our discriminant is greater than 0. So this means so far we have what? We have real roots. Then from here we are going to take this root because we have a positive number, or we have a positive discriminant. So this means so far we have what? Two unequal roots. Then from here you can see that we still have options of roots. So it's either we take this root or this root. Remember that 25 is a perfect square. So it means we are going to take this root. Remember that a perfect square is a number that is obtained by multiplying an integer by itself. And when we multiply 5 by itself, we are going to get 25. So this means we can conclude that our nature of the roots here is rational roots. Lastly, we have discriminant being equal to 30. Back to our diagram again, you can see that from here we are going to take this root because we have a positive discriminant. Then so far it means we have real roots. Then from here you can see that we still have options of the roots. You can see that our discriminant is not equal to 0, but it is equal to what? It is equal to 30. Then it means that we are going to take this root. It means that so far we have what? 2 unequal roots. Then again, we still have what? The options of the roots, meaning we can take this root or we can take this root. So you can see that 30 is not a perfect square. There is no a number that we can multiply it by itself then obtain 30. So it means that we are going to take this root. It means that we are going to have a rational root. So here our answer will be a rational root. I'm sure you have realized that to understand or to be able to answer the questions that are related to nature of the roots, you have to be able to understand and to interpret this diagram.